Hi everybody. I thought we'd have a look today at how we can build software for ARM targets like say the Raspberry Pi and use GitHub Actions to automate all of that for us. And that kind of gives us some kind of cool stuff. So what it means is that when we make changes to our code and we push it up to a GitHub repo, we can kick off automated builds and tests and see that things work, and then we can accept PRs from people and auto test those. Makes life a lot easier. This comes from the work I do maintaining the open source Yocto Meta Mono layer, and that's quite a time-consuming thing to build, and it takes a bunch of testing. So I wanted an easy way to facilitate building and testing things in the background, basically, and I've got that now. And that all comes down to GitHub and CI workflows and self-hosted runners, which means I can build on my own hardware instead of using some kind of cloud hardware. Main reason for that is because when I'm building something like Yocto, which is a full embedded Linux distribution, takes a long time, and often in the cloud, you either can't do that because you get cut off after a couple of hours, or it's going to get really expensive. So the key things here are GitHub Actions, self-hosted runners, and what we're going to do is we're going to build on a Raspberry Pi, which is pretty neat. And I was talking to a couple of guys on Twitter there, hey Phil, who are interested in this stuff, so I thought we'd give you some background. First thing, we got a web page up. This is connected into something called ProxMox. ProxMox is like awesome. It's a virtualization environment. You run it on top of some real physical hardware, and then it allows you to run virtual machines and containers on top of that, and start them and stop them and give them different resources and all this kind of thing. So I use this in some x64 Intel systems or AMD systems that I've got in the cloud to do sort of heavy duty CI building. But I recently discovered that ProxMox has been ported by some super clever people to run on the Raspberry Pi, which is really neat. So in fact, what I should do probably is ProxMox for the Raspberry Pi. And if you sort of wander around here, I think there we go. There's a GitHub repo, PyMox 7 ProxMox for the Raspberry Pi. Now, I'm not going to take you through all the installation of all of this stuff today because it would all take quite a long time. I just want to give you a flavor for what we can do. So I got all of this installed onto a Raspberry Pi, which is over in the office at Liverpool, and that's sitting there quite happily. I wanted a fair bit of storage for my Raspberry Pi, so what I did was, you can't really see this. This is over in the cabinet there. That up at the top is the enclosure that's got. There we go. That's it. The enclosure that's got the Raspberry Pi 4 in it, and that is an Argon 1, which you can get from our lovely friends over at Pi Moroni or elsewhere. Nice little box. You can see on the back there, it's got the connectors for the Pi. There's a little USB doobry here, which connects down to the base, which has got space for an M.2 SSD in it. And that's really lovely. So that gives us kind of as much quite speedy drive storage as we want for our Raspberry Pi. I suspect that there's a limiting factor going over that USB bus, but I'll leave that for other people to investigate. You do what you think best. That's my setup. So I have my ProxMox running on the Raspberry Pi there over at Does, and this is our base system, which I've called ProxMox Pi. And this is really neat. You can get a summary of everything that's going on in the hardware, CPU utilization, memory utilization, network traffic in and out. You see, I've got it's an 8 gig Pi that I've got in there, and that's what I'm using at the minute. And then what I did is I created a container, which I've called GitHub Runner, on that base ProxMox installation. And I've only got the one because I'm just doing sort of GitHub stuff on this box for the minute, but I could have all sorts of things going on if I wanted. Now we look at how I've set this thing up, that's the summary for what this container or virtual machine is doing as opposed to the whole physical system. So you can see I've given it up to 6 gig, leave a little bit spare, and I've been doing a bit of testing, so there's some CPU utilization and what's been going on with the disk. Not a lot seemingly, which is interesting. And you can see that I've given it 4 CPUs, up to 6 gig, bit of swap, which really we wouldn't be using. You don't need to worry about the boot disk. And if I then kind of look at that, you can see here that I've given it a 64 gig root disk size on the SSD and the M.2. And that's because, you know, we're potentially doing some quite big builds here, so I wanted to give it a fair bit of space. Now, one of the really cute things is that if I want to make that disk bigger or smaller, I can just click resize disk, boom, it just works. It's absolutely fantastic. Love that. That's really cool. And then it's sort of network stuff. At the moment, I've got this on an internal NATed network, which I can pull forward to if I want to. You do all this stuff. But basically, what we've got is a GitHub runner that's connecting out to GitHub and waiting there to be told to do stuff. I'll show you that in a sec. So this is our GitHub runner. I can then connect into this container, and I can have a little look at what's going on. If I do that now, created a GitHub user, and I'm in. This is the GitHub home directory. And what I've done is I've installed like a GitHub stub, basically, which is the GitHub Action Runner, which you get from the GitHub site. And that's up and running now. I use some kind of neat process management tool called PM2, which I got from the clever people over at Node-RED. And that, as you can see, is running our GitHub runner as a GitHub user. And I can probably, I think it's GitHub log 0, is it something like that? And you can see some logs out of that now. That's running. It's telling us that I've been doing a few test jobs so that I can show you some real things happening. And those test jobs were running, and the last couple succeeded. And you can see things happening. You can enable debugging for that. You can see much more of what's going on. But that's basically there. That's what that's doing. And you can see in here somewhere, yeah, you know, the GitHub runner is running and listening and connected. And we'll come on to another aspect of this a little bit later, which is that I find it quite useful to be able to build within a Docker container, because that for me is a really controllable environment. You know, I can control all the versions of all the software components in that container, keep them the same, and I can have different containers on the same host system to do different things, which is a useful thing, I think. Now, so just to kind of go back through this, because it's a little bit funky, I've got a physical Raspberry Pi 4 device. I've got a virtualization environment, which is ProxMox 7 running on top of that. I've got a container, which is running in that virtualization environment, which is our GitHub runner. And I've installed a Docker host inside that container, so I can run nested Docker containers in the container. Maybe it seems like overkill to you, but I quite like that, and it gives me the features that, as I say, can build in different Docker containers, but also I can back up and remove this GitHub runner if I want, reinstall that somewhere else, do something else with it. And this is all, you know, we get some flexibility out of this. So that's what that's doing, basically. Now, if I then go over to what I've been just putting together for you as a little demo in the Dynamic Devices organization in GitHub, which is a Hello World CI repository. This is really, really simple. This is just, as you know, as we all do, this is a Hello World application, which happens to be in C++, because that's what I found on the GNU page that Google gave me, and it's just going to print Hello World to the output, console output. And it builds with CMake, mainly because I like CMake. It's a pretty simple example. The CMake list that causes all this magic to happen is basically just saying, set up a Hello World project and build this Hello World source file, make this Hello World executable. And CMake does all sorts of magic stuff about figuring out what your environment is and building on it, that type of thing. We could go further. I've got some sort of autoconf tools that I use for other projects within the Yocto environment, but I think this is probably as far as we need to go for this example. Tell me if you'd like to see other examples, we can do that. So that's all to the good. Now I can clone that myself if I want. I can, and I've got a copy of that here on my local system here that we're kind of recording on, which is x64 laptop. And what I can do is I can look at that, and I can use the CMake. Typical way of doing that is to make a build directory, go into it, CMake ... to get the CMake lists from the directory above. It kind of goes and figures out what's going on in the environment. That sort of figures out where my C compiler is, C++ compiler is, that type of thing. And that's created the setup for a make, which is ready to go. That's my make file. If I do make, that's now built my Hello World application. You see, built target Hello World. And if I run it, ta-da, Hello World. Now, as I say, that's on my host system, which is an x64 system. So it's that architecture. That executable, as we know, wouldn't run on an ARM architecture because it's a different ISA, different instruction set architecture. But the CMake should help us to make it easy to build on the Raspberry Pi system, which is what we're going to get to next. So let me go back. I'll just get rid of that to clean up after myself. And the next thing is the bit of magic that makes all of this GitHub CI work is in a .github directory. We've got a workflows directory, and in that we've got some YAML, YML, which is a kind of format for scripting up essentially what the GitHub workflow is going to do. And every time you interact with a repository, like committing code into it, pushing code into it, GitHub does some magic and goes and checks for these kinds of files in this place. And if it sees something that's configured for the parameters of what you're doing, like your particular branch, your pull requests, that type of thing, it will start executing. It's really neat. Now, this is the fairly straightforward little workflow that I've set up here. I think what we'll do is we'll probably go back to that, but suffice to say, this is going to build up our Hello World. And what it's going to do is build it on a self-hosted runner, which is running Linux on the ARM64 architecture. And what I've done is I've set up runners that will pick up these jobs. You can use GitHub's own runners for jobs. It's what a lot of people do. For this, again, partly for control reasons, partly for long jobs, building Yocto and that type of thing, I'm really interested in self-hosted runners. So if I go to the settings, I can set up a runner in this repository here. And what I've tended to do is I tend not to set up specific runners within specific repositories. Instead, what I've done is set up runners within my dynamic devices organization, and then I've set the repositories that they're interested in supporting in terms of running CI. So I have control over what repositories, what runners run on. And in this case, I've got a runner here, which is an x86 runner that I host in the cloud for the big Yocto jobs. And the runner that we're having a look at here is this GitHub Runner 2, which, as you can see, is self-hosted on the Raspberry Pi or within the Raspberry Pi container, and it's a Linux ARM64 architecture. It's idle, which is indicating that I showed you the process was running before in the GitHub Runner container. That's connected, and it's idle, sitting there waiting for something to do. So let's give it something to do. Next thing is, if I go to GitHub Actions, this is the log of where all this kind of workflow stuff happened, and you can see things work, you can see things fail. Little green light good means everything worked, and you can really get very complicated with this if you want. I'm still a bit of a noob at it, but it's doing the things I need it to do. What I can do is I can go back to my Hello World application here, and I can say edit that, and change it to hello pi 4 world, say. And then I'm going to add that into the Git, commit that in. Hello test build. Save that, and then I sign my commits as I suggest we might want to be doing in the secure world we care about. Oh, I haven't signed my commit because I can't type the password, so let's try that again. Hello world test build CI. And there we go. So that's gone into the log. See that there. And we're going to push that up to GitHub, and off that has gone. Boom, up into GitHub. Now, what then happened was, as I said to you, GitHub has scanned through for these workflows. It found one, and it found one that is kind of relevant to what it should be doing, and I'll tell you about the parameters for that a little bit later. And it started doing the building. So what it's doing now is it's starting the job. It's looking for something that's an ARM64 Linux self-hosted build system, which we happen to have. It's found that that was sitting there idle, and that's, as we know, our sort of our GitHub Runner. What I can do is maybe if I run the logs here, we should see, yeah, it started to run a job now. And if we go back to, we're interested in that, but we don't need to worry about that side of things really. What we can do is look at what's happening on the GitHub action. This is really, really neat stuff, So remember, this is all building over on my hardware, over in Does. I'm here at home on a Sunday afternoon. I'm looking at the GitHub portal, which is telling me what's going on over there. I've been looking for this for years. So the first thing it does is it's initializing up the Docker container, because as I said to you, I'm building inside a Docker container in my own virtualized environment. So it's pulling down the particular Docker container which we're using, which is a Debian built container for the Raspberry Pi 4 from the lovely people at Balena.io, who do an awful lot of this very clever stuff. And it's already pulled a lot of that down, actually. That's cached on the machine. So that's there. And it's now checking out the Hello World repository, which it's just done. And it's now installing some build dependencies, because the Balena Docker image that I've decided to use doesn't have CMake by default. So I'm adding in CMake to that image, and that's coming down now, installing now, and some dependencies for CMake. And then when that's done, we should be good to go to start the actual build. So that's unpacking. I'll take a sip of my coffee while that happens. And there we go. Now we're doing the build. And then that was all pretty fast, wasn't it? Because it's an Node application. But we did a little test, and you can see, this is what I just changed before. So you can see I'm not lying to you. Hello Pi 4 world. Isn't that neat? Now, of course, that's just sort of showing, the thing worked, but you could have all manner of interesting unit test cases there. And if you failed on those, you could take actions on that. You could inform people that there were problems, and you could really manage your CI very well. But what happened was that worked. For our purposes, we can see it outputting hello world, so that's great. Another little feature that I wanted to show you is that with this GitHub Workflow stuff, when you've built your output, tested it, if you want, you've proven that it works, you can then upload and store the artifacts of what you've done for you to use or other people to use as you see fit, which is I think really, really helpful. I actually use this for some of the other commercial projects that we're looking at, and what I've set this up to do is to store this just hello world executable artifact that we've built, and I've stored it with the SHA hash of the git commit that caused all of this to be triggered and built. So that gives us an output set of artifacts built and tested from a unique commit, which we can go back to at any point in the future, which is all of you who manage devices, DevOps, that kind of thing, know when you run into a problem and you want to go back, figure out what might be going on, the ability to drop back to the exact binaries, code, systems, setups that you had 6 months or a year or a few years ago when all of this stuff went out can be really, really useful. So I like that stuff. And there we go. And then it just does some cleanup at the end of that process. If we go back to that action, we see it was green lit. And down at the bottom of the action, there is the artifact that we uploaded. And if we download that to my local system here in a zip file, it's got one file in it, which is the hello world file. And if I wanted to, I could go and throw that onto an ARM-based system or Raspberry Pi 4 most easily, run it, and it would work. Isn't that neat? So what I'm going to do is try something slightly different now. I don't know if this is going to work, but we will see, because I wanted to show you how this helps with working within team environments, this type of thing. So I use pull requests, PRs, quite a lot in terms of my usage of Git, my development work, which I'm sure you know all about. What I'm going to do is create a branch called CI build test, and then I'm going to edit our hello world application again. So from this pull request, save that. I'm going to add that to the branch. I hasten to add, I haven't actually tested this with this repo yet, so I don't know if it's going to work. But if you look at the branch, we're on that branch now. What I'm going to do is push that branch up to the to GitHub. Now, actually, that's not going to cause a build to happen. If we look at the GitHub Actions, you will see, if you got that right, it didn't cause a build to happen. The reason for that is because in our workflow, we say that we build on pushing to main or a pull request. So what I'm going to do, I could change that from main to that particular branch that I'm building on. But what I want to try to show is pull requests. So I'm going to try and create a pull request. And you can see that it's helpfully telling me that I've just pushed a branch up. So what I'm going to do is create a pull request from that branch, and it's populating that with my commit, signed off by me. I'm going to create the pull request now, and it's telling us that there's no conflicts. It's read that workflow YML, and it's realized that it needs to do a build. Now, I love that. I think that's just awesome. I don't have to do anything here. I can just, this PR can come into me from a team member or somebody in the open source community, and it's now building and checking all of this before I even have to get involved. Obviously, there are some security implications, in particularly in running this stuff on your own hardware, and there are some limitations that you can make in terms of who can create pull requests, what will trigger off these builds, all that good stuff. But the actual idea behind this, I love very much. You can see that it's telling us that this is running now. If I go back to the actions, this action is running from that branch that I put in on this pull request that I opened, and it's doing the same thing. It's running that up. It's just going to do the same thing as it did last time. It's setting up the container environment. It's going to do the build and do the test, and hopefully that will sort of come through quite quickly actually for us. While that's happening, I could also just show you, for interest's sake, that if we go onto the terminal for the container where we're running all of this, the GitHub Runner, that's still looking at the log, which is saying that it's now building this new job. What's possibly worth pointing out is that you're interested in the Actions Runner, and in the Actions Runner you're interested in the work environment, the underbar work environment, and in there you can see that's where stuff happens. So all the things that we're looking at that are getting built and tested, and that in this case are here in this tree in Hello World CI, and in fact what will probably happen here is that there will be a build folder created when we get around to it. Then it's not there yet, and then the executable will be created, and we'll probably run that and see that. So you've got kind of access into that. what's interesting here too is that this is the container on ProxMox 7. We're building in the Docker container, but the Docker container mounts the underlying file system. So after the Docker container is finished and removed, we've still got access to the artifacts if we don't want to clean them up to look at what was done, which is nice. It's good for sort of speeding up builds through caching and that kind of thing as well. So where are we? Let's go back to the hello world stuff. My word, while I was speaking on, we've completed the job and it's worked. Presumably then, if I go back to this, we do indeed now have a build folder, and if I go into that build folder, I can run the hello world application. And you see it's from this PR, because would I lie to you? No, never, of course. How fantastic. If we look at the output of the test that we did, the naughty little test, you see the same thing. Hello, powerful world from this PR. And then we can go back to the pull request. And in the pull request that I created, that's now gone green. So whatever build and testing I chose, or you chose, or we chose to put in here, I can now go into this as a maintainer and say to myself, aha, I'm happy with that, you know, so I can do a little review of whatever they've put in. And in fact, we could lint it as well, and we do all that type of thing. And I can choose then to merge. But it gives me that level of confidence that when I merge this stuff in, it's not going to massively break anything. And I think, for me, that's really very much a step in the right direction. It's the kind of thing I've been looking for many years. And there's other stuff that I do here in terms of taking the output artifacts and then pushing them onto GitHub pages, so we can then do firmware updates into devices, and we start moving from CI or continuous integration into CD or continuous deployment, which is a whole other brave new world, which we'll go into another time. So that's kind of what I wanted to show you, because I really like this. I think this is a really nice setup. Now what you don't need to worry about this, but if you're interested in ins and outs of what's going on in that workflow file, we have a little talk about that to finish up. And here, this is pretty naughty, but I've tried to annotate it for getting into it. So we've got kind of, you know, the name of the what's going to happen, and then we've got when is this going to happen. So it's going to happen on a push to the main branch, and we can change all of this around. It's also going to happen on a pull request. If that wasn't there when I raised the pull request, nothing would happen. And then what are the jobs that we're going to do? I've just got this simple job: build it, test it, store it. That's what we're going to do here. And I say that job must run on a runner with these labels. It must be a self-hosted runner, it must be running Linux, and it must be ARM64. If I was doing sort of cross-compiling on the big iron stuff that I have in the cloud, I'd be saying x64, and we'd be doing some other things. That's more complicated. Then I've said, rather than doing this all within the actual runner environment, which could be the host system, in our case it's the ProxMox container, I don't want to do that. I want to run within a Docker container in that environment. And I've chosen to use, again, I think I said earlier on, one of the images from Docker Hub. That's where these come down from by default, which is the Berliner Lib Raspberry Pi 64 Debian build. I'll show you that because Docker Hub is also rather neat. Go into Docker Hub and we have a little search for that. Okay, that's not going to make sense. Because of that. Let's just go to Berliner Lib then in that case. Yeah, and you see there's a load of different images that the Berliner people have kindly put together for us. And I should be able to find one, I think, in there, maybe. I can't find it, but it's in there anyway. The Raspberry Pi 4. There we go. Ubuntu, Alpine, Debian, loads of different images, really neat. We're going to look at one of those, so Raspbian. Look at the tags for those. You can see that that's running on Linux ARM v6, and those are the architecture tags. So that's related to what GitHub is then pulling down to be on the right architecture to do the right build. It's all really super clever. There is a latest of all of these things. It's interesting. I've chosen to use SID because that was the most recent that I saw in there earlier on today, and I wanted something that wasn't tagged as latest, because latest can change, and in theory that shouldn't change too much and break in the future if you ever decide to have a go at this yourself. First thing it does then is it gets that container down and it starts running that up. Then it checks out our Hello World repository, which I've taken you through, haven't I? And then you saw it install those dependencies. That's where we installed CMake. The next step is to do that CMake build, which is what I showed you on the local system. So we make the build directory, run the CMake, run the make. That gives us the output command. And my testing is very, very basic, just running up that to see that there is some output there. Presumably, I think if that Hello World had not built for some reason, then that should error and tell me that it had errored. And then the last step, I just wanted to store that artifact for posterity. So, I hope that all of that gives you some kind of introduction to what I'm up to here at Dynamic Devices with continuous integration on embedded platforms. I hope that that's interesting. I really like this, and if you have any thoughts on where it could go, or whether you're using it in anger, or whether you think things could be improved, I would really love to hear about that. You can tweet to me at embedded_IoT on Twitter, or just send us an email. It'd be great. So I will wish you a happy Sunday afternoon, whatever day it might be today, and see you next time.